Everybody, I think we're going to get going. So there'll be a few more people join us, but we got a decent crowd on so far. Thanks for taking the time to tune in to our live stream AIM meetings today. We got a few people in the office in the meeting room, but most of you are joining us online. We've had 3 in-person meetings with growers yesterday and today, and they went well. And then for those that weren't able to make it to those, we're doing this online. So the main speaker today is Andrew McKenzie-Gopsill with AAFC in Charlottetown. Andrew's going to talk a bit about different weed control options, herbicide options, talk about herbicide resistance management, talk about cultural practices that can help reduce weed pressure, all those sorts of things. And then at the end, I'm going to have just a handful of slides, just with a couple of things coming up with either the board or some other upcoming meetings going on. So I'm going to hand it over to Andrew to start us off.
All right, thank you. So yeah, I'm Andrew McKenzie-Gopsill. I'm a weed scientist at Agriculture Canada here in Charlottetown. And I just want to also thank my graduate student, Laura Anderson, and acknowledge her. I pulled a bunch of slides from her presentation here at the end that we'll talk about. She's been working on this triazine resistance story with me.
Oh, and Andrew, I guess I forgot to mention too, we will be taking, we'll stop a few times for questions, just because you're not in the room and can't just ask questions anytime, but questions are welcome at multiple times. And so we'll try and remember to take a few breaks for questions. And so if you have a question, you can take yourself off mute and ask it, or take your video off or put your video on and raise your hand, or you can raise your hand on the Zoom menu, and I'll get Morgan to keep an eye out for you. Morgan's helping me run the Zoom here, so feel free to ask questions. We'll try and make sure we get a bunch of them in.
Yeah, sometimes I get on a little bit of a roll, so feel free to interrupt me. That's okay. All right, yeah. So weed management in potatoes. It's going. No, it's not going forward. Nope. Sure. All right. Oh yeah, just click on the screen. Perfect. All right. So this is some data going back over 30 years now. This is a collection of studies. These are all from Prince Edward Island, though. This is all a collection of studies from Jerry Ivany, Will Proctor, Lorraine McKinnon, and this is just trying to get a measurement of how much yield is lost due to weeds. So what this data is whenever we have an experiment where we have a weedy check, or where we've got no weed control, and then we have another treatment where we have at least 95% weed control, we just compared those studies to get an estimate of marketable yield loss. So we've got a total of 37 different studies in here, said going back 30 plus years. And while we do have some years where we can approach over 70% yield loss, overall, on average, across varieties, across unrelated studies, we're seeing about 30% yield loss due to uncontrolled weeds in potato. And this is being put together by the Weed Science Society of America's Yield Loss Committee. They've been doing this for a variety of different crops. And yeah, recently reached out to me about potatoes. So how do we manage that? Well, my approach, and really the approach that I would advocate, is taking an IWM, or an integrated weed management approach. Integrated weed management is a subdiscipline of integrated pest management, just focused on weeds. And the whole point of integrated weed management, or integrated pest management in general, is trying to get away from single mechanisms of management and try to combine multi-mechanisms of management to try and really create that holistic, integrated approach to managing weeds long-term. So this can involve aspects of chemical control, as well as biological control, mechanical control, and cultural control, all in an effort to try and build that integrated program to really prevent our weed issues from continually being a problem going forward. Now, today I'm mostly going to be talking about chemical control to start out with. Do have a little bit of data on biological control, but I don't really, when we talk about biological control, I often think of like the classic biological control where we're releasing insects or diseases to try and control our weeds. In terms of agricultural systems, that has not really been largely effective. So when I talk about biological control, it's really trying to utilize the biology of our weed species, sorry, not of our weed species, but of our cropping system to try and maximize weed control. That can be through things like mulching or turn-eating cover crops or anything. As well as mechanical control, we're just starting to get into that. Not too much. I'm not really going to present anything on mechanical control, but we have done a couple studies that kind of complement some of the work that I have been looking at. And yeah, that's all from my graduate student, and that'll be at the end there. And then as well as we got some data on some cultural control or cover cropping and the effects of cover cropping prior to potatoes. So as I said, we're going to start out with chemical control, but the first thing I want to just briefly touch on is proper weed identification. Every single integrated pest management program is, the first step is always proper identification of issues. So know your weeds, identify them accurately, and then adjust strategies based on what weeds are actually present. If a weed is misidentified as a perennial or as an annual and it's actually perennial, or it's a perennial and it's actually an annual, some of your products that may target either annuals or perennials may not work, and it may have nothing to do with the fact that that the herbicide didn't work. It's that the wrong or the weed was misidentified. So again, I don't really want to get into weed ID, but we'll start out with we can group weeds into two large groups, monocots and dicots, and for basically that's your grasses and your broadleaves, where monocots are your grasses and your broadleaves are your dicots. So just a couple of major problem weeds. First, here on your left, that is quackgrass or couch grass. That's really one of the only perennial grasses of agricultural significance that we find here. And a couple of key features for identifying it is this thing spreads by rhizomes. So if you pull one of these things up and you see this rhizome network here, good chance you're dealing with quackgrass or couch grass. And then also you're going to look for that clasping auricle. So this is right where the leaf blade meets the stem. You pull that back, you should see what are called auricles actually wrapping around that stem. And again, really the only grass of agricultural significance you're going to find that has that is quackgrass. A couple of the other annual grasses, smooth crabgrass, large crabgrass. I'm pretty sure most of our smooth crabgrass is hairy though, so not really the greatest common name. Just some variability within our biotypes. And then here's foxtail, a very distinctive seed head. That's a foxtail leaf. Tends to have hair on the top of the leaf surface. A couple of the broadleaf weeds, chickweed, so that's pretty common. Corn spurry, that's one that I had never come across before moving here, but it is everywhere here. That's just one that's not present in Southern Ontario. Whenever I send pictures of that to people back home, they have no idea what I'm talking about. But yeah, it's very prevalent here. Field mint, another one that seems to be more of a problem here and not one that I really come across as being an issue. But to identify any kind of mints, generally they have a square stem. So you can pull that thing up, look at the cross section. If you've got a square there, you're generally dealing with a mint. As well as, while it doesn't smell as nice as like mint that you buy in the grocery store, it does have a scent to it when you go and rub it between your fingers. And you can eat it. It's the exact same species. There's nothing wrong with it. And moving on to bed straw or catchweed. These are your gallium species. So we have a couple of different ones. They also have a bit of a square stem, but they are not mints. They're not related at all. But they have, we call it an angular stem. We've got a couple of different species. This one here, this is your sticky one. Some people call it catchweed, bed straw. You had a whole bunch of different names, but you can take that, bundle it up in a little ball, and it will stick to your hand if you just hold it there out like this. Like it's those little hooks on there are really sticky. Then we have smooth varieties of that as well that are just don't have any of those little hooks on them. Another big group of problem weeds, that would be your knotweeds, your buckwheats, your smartweeds. They're all within the same family. That's the Polygonaceae. And this one right here, that's lady's thumb. It always tends to have that, or every population I've seen has that distinctive marking on that leaf that lets you know that's lady's thumb. And then another key diagnostic feature is this. So that right there, that's called an ochrea. It's right where the petiole meets the stem, and that is a key feature of that family. So if you look at the plant, it has that. You're probably dealing with a knotweed or a buckwheat or a smartweed. This ragweed looks a lot like carrot. Not as common here, but still present. And we've got a couple of sow thistles. You got your perennial sow thistle, and we've got a couple of different annual ones. And then here at the bottom here, so this is redroot pigweed versus lamb's quarters. So when they're really tiny, they can be quite difficult to distinguish between the two. But in general, redroot pigweed, a little bit redder here and a very distinctive mid vein on that first set of true leaves. These are cotyledons. That is your first set of true leaves. And then compare that to lamb's quarters. Scientific name of lamb's quarters is Chenopodium album. Album is Latin for white. If you think about lamb's quarters, it's kind of all that hair on it. It gives it a bit of a white color. So when you're looking at them when they're really young, if it's got a bit of a whitish tinge, chances are it's lamb's quarters. If it's got a distinct mid vein and some redness there, it's probably redroot pigweed. And I believe we only have 2 species of pigweed that I've come across. Redroot would be the most common one. And then we have a little bit of green pigweed at Harrington. A couple of resources. I would highly suggest this one, Weed ID Guide for Ontario Field Crops. That's recently produced by Mike Cobra. He is the weed extension officer with OMAFRI in Ontario. That guide, it's really a follow-up to this one, a field guide to broadleaf weeds, and then on the reverse of that is the grassy weeds. And this is specifically designed for producers who is funded, or funding came for this from Grain Farmers of Ontario. And what I really like about that is it's all your agriculturally significant plants, as well as it has a little line in there of, I know it's not X plant because this. And so it'll oftentimes give you, here's a species that is often misidentified of this, but it's not that because it has this. And so it can be really useful for especially picking apart some of those tougher to ID weeds. Some of these other resources really good, but like Newcombs and his Weeds of the Northeast, unless you're a botanist or really interested in this kind of stuff, I would recommend, or not recommend these as much. That's really more for people who are really into plant ID. Okay, so moving on to some herbicide terminology, actually getting into weed management. So I just want to go through a couple of key points that will help as we go through all of our herbicides. So first would be mode of action, and that is the entire sequence of events from the herbicide uptake to how that herbicide works in its target site within the plant to how it actually causes plant death. So that entire sequence of events, it would be your mode of action. We have about 30 different modes of action that are currently registered, a few less than that in Canada, but each group of chemistries has a unique mode of action. We classify them by numbers, and every single herbicide within that group would have that same mode of action. Then residual, that's the length of time a herbicide is effective in the environment. So products that would have no residual activity, these are like your contact herbicides, and you spray them on and then they're not going to work any longer. But any kind of our pre-emerge products, we're really taking advantage of that residual. And so however long it stays in that environment, that is what we would term its residual activity. I am not, in terms of how they actually define and calculate residual, I am not totally clear on what conditions that's used in. So while their residuals are reported in weeks or months or season long, again, I don't know what conditions those were done in. So I would say in our environment, really maybe half those values that you see that are on the labels would be just from my experience. Next, selectivity. So selective herbicides are herbicides that kill or are effective on certain groups of plants. Non-selective herbicides just really control everything indiscriminately. Think of glyphosate or Roundup, just controls everything. Versus selective herbicides, you think of like your grass herbicides, your group 1, so those only target grasses. You've got your group 4s, your 2,4-D, MCPA, and those only really target broadleaves. And so you've got selectivity there. And then there's really more finer selectivity within each one of those herbicides where they may control certain groups of grasses or certain groups of broadleaves. Next on use patterns. So the three patterns that I'd really talk about would be pre-plant or pre-plant incorporated, and these are products that are applied before actual planting happens. This is really kind of like a burn down. You want to kill everything that's there before you go in and plant. Then we've got pre-emergence products, and some of these will have, they would have pre-emerge activity, but some of them do have some post-emerge activity, so they're effective on emerged weeds. But when I say pre-emerge, I'm referring to the potato. So that's pre-emergence of the potato. Then post-emergence, whenever I'm talking about post-emerge products, we're referring to post-emergence of the potato. So that's, while some pre-products have pre and post activity, when I say pre, it's pre-potato emergence. Lastly, just a quick disclaimer, use of a product name does not constitute endorsement of that product. When I generally speak to my colleagues, we talk in active ingredients. That doesn't usually work very well when you go and speak to producers because they don't purchase products in active ingredients, they purchase them with a trade name. So the trade names that I'm using here, just so that it'd be a little easier to relate, they're the ones that I'm most familiar with. That does not mean that I endorse use of that product over any other ones, and there may be a variety of different options from different manufacturers for some of these products. I am not advocating use of a single product over any other, so just make sure that you, when you see a certain name, it doesn't mean I suggest you use that over anything else. So we went into the actual herbicides. So these are your before planting herbicides. I would really, like if you've got heavy weed pressures or perennial weeds are an issue, this may be a good strategy. So we're just going to talk about Eptam right now. This is one I have no experience with it, and this is our fourth presentation now, and nobody that we've spoken to has ever used it. Ryan was mentioning that it seems to be a product that is used out west where there's a lot less rainfall because of this key point. It does not need rainfall for activation. So this is a group 8 product, inhibition of lipid synthesis. I'm not really familiar with any other group 8 products, and I have never used a group 8 product. So yeah, this is all just kind of pulled from the literature. I don't have any experience with this. Use rates are between 1.25 and 5 or 8.5 liters per hectare. I apologize for putting everything in liters per hectare. You can more or less convert that to pounds per acre. It's almost a one-to-one conversion, but always make sure you check the label before you go and actually use anything. Higher rates for denser stands. Uptake is via underground plant organs, so your roots, seeds, and because of that, this product has to be soil incorporated. So either disc, cultivator, or with a little bit of irrigation. Whenever I refer to irrigation being used to incorporate a product, I'm referring to about half an inch of irrigation, so 1 to 2 centimeters of irrigation, and that's kind of a general rule of thumb for everything. One problem with this product is it's susceptible to leaching with heavy rainfall. So if heavy rainfall is forecast, this may not be a good strategy. Primarily targets grasses, however, it does have some moderate activity on some of our problem weeds like corn spurry, lamb's quarters, nightshade, pigweed, and chickweeds. Allegedly provides season-long weed control, but again, I take that with a grain of salt. And you can tank mix it with Sencor. But if you tank mix with Sencor, drop the rate of Sencor to the max of 0.75 kg per hectare, which I think is probably higher than most people would use anyway here. So that's all I really have to say about Eptam. Again, it's not a product that I have any familiarity with, and yeah, we're at least doing this to almost over 50 people now. Nobody we've spoke to has ever used this product. So now moving on to our true pre-emerge products. This is generally what most producers would be familiar with. I've grouped them into 3 kind of categories. These Sencor, Lorax, Dual, and then Boundary. So those would be, most producers would have familiarity with Sencor and Lorax. Dual, maybe seen a couple people have used it. So maybe a little bit of familiarity, as well as it's used in a couple other cropping systems like soybeans. But yeah, so we're going to go through those and then move over to glufosinate and glyphosate, which you may be familiar with, but not used within potato production or haven't used in potatoes. And then lastly, we're going to get to these three: Frontier Max, Reflex, and Sencor STZ, which, yeah, these are kind of the newer products that you may have really limited familiarity with. So every single one of my herbicide slides looks like this. So we've got everything listed: group, rate, when you apply, uptake, and then groups of weeds. So this is kind of the standard format going forward for all of our herbicides that we're going to be talking about today. So yeah, Sencor 75DF, that is metribuzin. That is a group 5 photosystem 2 inhibitor at a particular site on photosystem 2, because there's a couple of different groups of photosystem 2 inhibitors. Use rates between 0.55 to 1.5 kg per hectare, but I think most people are down on that lower rate here. You can apply from planting up to emergence, and metribuzin or Sencor gives pre and post-emergent weed control. So anything that's emerged, as long as it's susceptible, should be controlled as well. However, uptake is primarily by the roots, but there is a little bit of uptake via foliage. So, you know, this is really more of a pre-product. It's going to be really effective if you can get it on there as the weeds are germinating. Rainfall is needed for full activation and to prevent crop injury on some varieties. And again, knowing how this product works, you need heat and sunlight to maximize efficacy. Photosystem 2 inhibitors, these products bind to that photosystem and prevent energy transfer. And so you need that energy to come from somewhere. It comes from the sunlight. So that's why you really want some sunlight to maximize how effective this is going to be. Has a whole bunch of registered tank mix partners. Check your label before you do any kind of tank mixing. But we are going to go through a couple of them today. It really controls a broad spectrum of broadleafs and annual grasses, which is why it's been kind of a foundation in most people's management strategies in potato. However, we have begun documenting lamb's quarter populations resistant to Sencor across PEI and New Brunswick. Really, anywhere where we look hard enough, we will find resistant populations. Okay, Lorox or Linuron. So this again, this is a group 7 photosystem 2 inhibitor, but at a slightly different site of photosystem 2. Use rates between 2.3 and 4.6 liters per hectare, can apply from planting all the way up to emergence. And again, similar to Sencor, pre and post-emergent weed control, but primarily absorbed by the roots, less so by the foliage. Again, rainfall is required to move that product into the root zone because it is being taken up by those roots. So you really want it where those weeds are germinating. You're going to get really good control of broadleafs, less control of annual grasses, but it's still there. This is not something I've seen, but Ryan was telling me about this, that on very low organic matter soils, there may be some injury when using Lorox. And I think that was less than 2% organic matter.
Yeah, definitely less than, or definitely in the low end.
Mm-hmm. So yeah, if you have very low organic matter soil, be conscious of that. And you can tank mix this with a whole bunch of different things, but one of the other ones that we'll talk to in a second is esmetolachlor, and that'll improve grass control. So where Linuron isn't as great on grasses, if you add in esmetolachlor, it can improve that grass control. However, do not use on coarse textured low organic matter soil or high organic matter soil, but I don't believe the label specifies what those organic matter values are. Ragweed populations seem to be resistant or develop resistant to Linuron quite a bit. My lab's identified ragweed resistant or Linuron resistant ragweed in Nova Scotia carrot production, where Linuron is really the foundation of carrot weed management. And we are currently investigating a suspected incidence of resistance in lamb's quarters from New Brunswick potato field.
Can I stop us for a second just to see if anybody has any questions? You can unmute yourself, or if you got any questions.
So Linuron's one that's been kind of up for reevaluation for the entire time I've been here, but they just released the full decision not long ago. I think at the start of last year, sometime during last year, and there was no change to use patterns in potato. So yeah, producers are still able to use linear on how you did before in potato. So there was no change there. There was some changes to some of the other use patterns. So if you're using linear on in a different system, make sure you check the updated label there.
Any questions or comments? Okay, we'll keep driving on.
Okay, so next one is dual 2 magnum or S-metolachlor. Now this is a group 15 product, inhibition of cell division. Use rates of between 1.25 and 1.75 liters per hectare. And you can apply it from pre-planting all the way up to ground crack. So there are variety issues with this product though. And as far as I'm aware, the potato variety responses are not very well studied. The actual label, I think, only makes reference to, is it superior? And yeah, so that's it. They just know, or within the label, it says, you know, try this on a 1 acre plot of a new variety before trying it on the rest of your field. So be very aware that there are some variety issues. I've used it on russet Burbank and had no issues. And somebody this morning listed a couple other different varieties that they had used it on with no issues. I can't remember the names of those right now.
Mostly processing.
Yeah, okay. So this product it's a true pre-emerge product only, no post-emerge control, because it is uptaken primarily or entirely by the germinating shoots and the shoots and roots of germinating broadleaves. So anything that's emerged here is not going to be controlled by dual. It doesn't matter if you spray it on them. Or well, it's not going to do anything. Controls annual grasses and some broadleaf weeds, a couple of the problem ones, so your nightshades, as well as a bit of suppression of pigweed. Rainfall is required within 10 days for maximum efficacy, and it can be soil incorporated to improve pre-emerge activity, and allegedly provides 10 to 14 weeks of residual control, but I would imagine probably half that in our conditions from my experience. In terms of recropping intervals, winter cereals can be planted 4 to 5 months post-application, so there is an opportunity there for a winter cover crop depending on variety and application timing. So a common tank mix that can be used in potato is S-metolachlor plus metribuzin. So this product is sold as a pre-formulated tank mix as Boundary LQD, and this is a group 5 plus group 15 product. So you got your group 5 for metribuzin there, or Sencor, and group 15 is your dual or S-metolachlor. If you're using Boundary, use rates are between 1.85 and 2.5 liters per hectare, but there's nothing stopping you mixing it yourself. Just buying a jug of Sencor and a jug of dual, but always make sure you check your label before you go and do that. Gives a broad spectrum of annual grass and broadleaf control, so you're going to get all of your the weeds that the Sencor normally controls, as well as some good control of grasses from the dual. However, this product will not control resistant lamb's quarters. S-metolachlor is not effective on lamb's quarters, so it is not going to control them if they are resistant to metribuzin. So if you know that that's a problem, this is not a product that's going to help solve any of your solutions there. And resistance to S-metolachlor has been documented in pigweed species in the US. That's kind of a theme that you'll see going out throughout this whole presentation, is that pigweed seems to become resistant to everything. Now, for all of these products that you may be less familiar with, I have a slide here after going through all that little bit of information just from our results. And to give you a little bit of context here, this is russet Burbank potatoes planted in 2018 and 2019. We plant, hill 4 weeks, 3-4 weeks after planting, and then apply our products immediately after hilling. In both years, we went in maybe an hour after the hiller left the field. We did this both in Harrington at our research farm, and then in Fredericton in New Brunswick at their research farm at Agriculture Canada. And so what you're looking at here, these two pictures, this one here on your left, these are both the same product has been applied, but in 2 different years. So the one on the left is your 2018. That is my field that has triazine-resistant lamb's quarters and a heavy, heavy weed pressure. So you're seeing a whole bunch of lamb's quarters growing above there. And that's because dual is really not effective on lamb's quarters. We saw moderate control of things like shepherd's purse, buckwheat, and smartweeds. And then smooth crabgrass seems to be pop up everywhere I go. So that was there as well. And then when we took the marketable yield, compare that to our weed-free, that's our weed-free check that we just hand weed, we see no significant difference there. Now this picture right here, this is our less weedy years. This is 2019. So you can just see what happened, compare it to a heavy density weed pressure versus a less dense weed pressure, as well as you have a resistant field versus a non-resistant field. I can see a question there. Okay. Yeah. Okay, so that's a good point. So there's a mixed load system, and yeah, most potato growers should be all right. Small change, and then yeah, that high rate, I don't think anybody is using anywhere close to that high rate. So, but yeah, good point. Gavin was involved in that whole process, so he's a good resource if you have any other questions about, well, anything relating to weeds, really. Okay. So yeah, it's dual. Click on the presentation. Next slide. There we go. All right, so this is boundary. So again, 2018, we have resistant lamb's quarters in here. You can see a few popping up. So anything that's susceptible to Sencor is going to be controlled by Sencor. But so that's what you see here, you know, nice clean field. But compare that in 2018 when we have resistant lamb's quarters and we don't get as good a control. Excellent control, all other species, again, some small crabgrass, but in terms of marketable yield, no hit, completely equal to our weed-free.
So we'll stop again for another minute or two. Does anybody have any questions? You can either unmute yourself, or you can put something in the chat if you have a question. I know dual and boundary are not used maybe as much by island growers. There's a few, we talked to a few people this morning that were used dual last year and got along well with it. Mm-hmm. And so it is starting to see maybe being used a little bit more. Anyway, just be, if anybody's got any questions or comments before we keep rolling. Okay.
All right. So Roundup. So this is glyphosate, sold under a whole bunch of different trade names, but Roundup usually, most people know what that is. It is a group 9 product, inhibition of EPSPS synthase. And it is the only group 9 product that there is. There's nothing else within that group. Use rates are going to vary based on product concentration. Depending on how much actual Roundup is in that jug is going to depend on your rate that you're going to use. But most labels, I think, break it up into annual weeds and then perennial weeds, and then different size classes based on 5 centimeter, 10 centimeter, 15, greater than 15. So you're just going to, as bigger the weeds and perennials, you're going to up that rate. It can be applied pre-plant and pre-emerge all the way up to potato ground crack. However, if there's a crack in that ground and the potential for that glyphosate to get in there, I would be very cautious. You do not want glyphosate to touch your potato. This is entirely post-emergent control. Glyphosate has no pre-emergent activity. It's absorbed entirely through the foliage and then is translocated throughout that plant. And that's really why glyphosate is so effective, is because it moves through that plant. So if you think about perennials, it takes that and then moves it in through that rhizome network to really take that thing down. It should be applied to actively growing tissue for maximum efficacy. Again, that relates to the fact that it translocates. We're relying on that plant to absorb sunlight, shunt sugars throughout its system, and then while it's shunting those sugars, to shunt glyphosate at the same time. So really, you want actively growing tissue for maximum efficacy. Had a lot of questions last year about late fall glyphosate applications. Again, depending on your environmental conditions, if things are still growing, it may be useful. But if, it's gotten so cold that things have really shut down, really not going to be very effective, and you probably won't see any real activity there. Glyphosate has no residual activity. It binds very tightly to the soil colloids, and yeah, so no residual activity. Potatoes can be seeded right after application.
I think that's an important point that came up in our other meetings, was about you can use glyphosate and not worry about planting potatoes soon afterwards. Like, there's some people that worry that there'd be like carryover effect, or that there'd be some other you'd have some, especially for like seed potatoes and that sort of thing, that as long as it's not touching the potato plant, it's fine.
Yeah. Yeah. Glyphosate is completely non-selective. With enough of it, it'll really kill anything, as long as it's not resistant, with a few caveats, and then some worldwide resistance issues that we'll get to. So that are kind of slowly creeping their way out here as well, but we don't have anything at this point. Next, glufosinate. So I know, like, the jug that we have is Ignite. It's sold as Liberty, and I think a couple others. So this is the foundation of that Liberty Link canola system. I learned yesterday that it was used as a top killer for, I believe, 1 year before there were some issues with that, and then that was removed. So this is a group 10 product, inhibition of glutamine synthase, use rates between 2.7 and 5 liters per hectare, and it can be, again, applied up to ground crack, but you want to avoid any potential for it actually hitting your potatoes. It's entirely post-emergent control, almost entirely absorbed by the foliage, and not really translocated. This product works quick, turns things crispy very fast. No residual activity, no recropping restrictions. Non-selective, perennials may regrow. So because this thing works so quickly and just kind of burns everything off, that perennial, it may not have actually gotten a chance to move down into that system, and so you may actually get some regrowth there. But it should, as long as you get enough on, it should nuke any kind of annuals. Limited incidence of resistance, mostly limited to perennial ryegrass in New Zealand orchards. Orchard systems tend to use these types of products a little more frequently, where trees and stuff can tolerate a certain degree of this. Okay, so those are the two post-emerge products that can be used in potato. So now we're going to move on to a couple others that would be true pre-emerge products, or more or less true pre-emerge products and less familiarity with. So the first one here, this is dimethenamine P. Originally sold as Outlook, but I think if you see Outlook, it's just an old jug now. It's really, I think, just Frontier Max. So this is a group 15 product, so similar to your Dual, inhibition of cell division. And I believe there's only 2 rates to use, a 756 and then a little bit higher one. I think it's around 900. But we're probably around that lower use rate. You want to drop that when you're with lower organic matter. It can be applied anytime after planting, as long as potatoes have not emerged. So that's key. Make sure your potatoes have not emerged. Do not let this product touch your potatoes. It gives only pre-emergent control, no post control here. Uptake is via the shoots and the roots, or the developing shoots and roots, but primarily through the developing coleoptile. Coleoptile is a grass shoot, germinating grass shoot. Because of that, it's very effective on annual grasses, less so on broadleaves, but is effective on a couple of our problem ones, pigweeds and nightshades in particular. Not effective on lamb's quarters. Provides season-long weed control. Yeah, again, caveat to that, but really you just want weed control until you hit canopy closure is really, that's the time frame when you're going to lose the most yield to weeds. Rainfall is required within 7 to 10 days after application. However, you can use shallow cultivation in the absence of rainfall just to move that product into that soil or into that growing zone. In cold, wet conditions, potato emergence may be delayed or stunted. I have not experienced that. But if you're in a cold, wet year and you've used dimethenamide P, be wary that that could happen. I am not sure if that has any kind of impact on yield. I guess it would really depend on how delayed and how stunted they are. Now, if you have crop failure, do not replant potato. Plant corn, soybean, or dry bean. Only a single application may be made per year, and do not apply within 40 days of harvest. A couple of recropping intervals, 100 days for cereals, so good chance you can get some kind of winter cover on there. And then next spring for potato, corn, soybean, dry bean, or cabbage, and then 11 months for all other crops. So really minimal recropping intervals. 2016, resistance documented in pigweed species in Illinois, because of course, and I can't remember what cropping system that was in. Again, consult the label before use. Just to show you some of our data here. So overall, we saw very poor control of lamb's quarters with dimethenamide P. We were rating it around 60 to 70%, and that's what you can see all in that picture on the left is just like a layer of lamb's quarters growing above those potatoes. And then all the little things in amongst, in that less weedy year in between this potato row, those are generally all lamb's quarters as well. And we saw less control of things like shepherd's purse, and then our buckwheat, smartweeds, knotweeds. And then again, always smooth crabgrass. And not sure why, I have no explanation for this, but we saw a small but statistically significant yield boost in marketable yield when we use dimethenamide P. So even though we have that huge like lamb's quarter population there, it seems that at least in our work across 4 site years, we see a small 10% yield boost with dimethenamide P. That was the only product we saw any kind of increase in yield relative to our weed free. Everything else was that worked with just kind of gave the same level of marketable yield.
Any questions on Frontier Max, glyphosate, glufosinate while we're in that section? All good? All right, you're a quiet bunch.
All right, next one, Reflex or Fomasafen. This is a group 14 product, so inhibition of protoporphyrin oxidase. That's involved in the pigment biosynthesis pathway, so your chlorophylls, carotenoids, and accessory pigments. Reflex only has one use rate. It's 1 liter per hectare. However, this product has pre and post-emergent control. So anything that's, or not anything, sorry. But if you have emerged weeds here, add a little bit of Agro 90 at 0.1% volume per volume, just to try and make sure that product can cross that cuticle layer and control those emerged weeds. It can be applied at planting up to emergence and provides pre and post-emergent control of pigweed species, but really just suppression of lamb's quarters. So if lamb's quarters is an issue, this product is probably not going to be very good. And then it gives post-emergent control of ragweed, wild mustard, those buckwheats, eastern black nightshade, and then canola, so your brassicas, your mustards. For control, you want to hit these things when they're early. For post-emergent control, max of 4 leaves for most of our weeds. All the other ones listed there except lamb's quarters for that suppression. It's got to be at the 3-leaf stage max. So again, you're dealing with things that are quite tiny. A couple of restrictions: do not cultivate within 7 days after application. Do not apply to soils with greater than 5% organic matter or fine texture. Do not apply Reflex to a field more than once every 2 years. This product is used quite a bit in corn and soybean rotations. So if you use it in one of those, do not use it in your subsequent potato year. You compared Frontier Max plus Sencor? No. So we have tank mixed Frontier Max with a product called saflufenicil or Aragon, which is, I think it's sold as Integrity, and that worked very well, not registered for use on potato. We have not tank mixed dimethenamide P with anything else and tried it yet. But something to do in the future. Do not harvest potatoes within 70 days of application. So depending on your market class, that might this might be a good product or not for you. And we have resistance documented in pigweed species across that soybean corn belt of the US where this product is used quite a bit. Again, consult the label before using. Our work, oh, can you click the, yeah. So what we find is we get really good control of that early emerging, that first flush of weeds, but it doesn't get that second flush at all. So gives you that really early control, and that's it. No control of lamb's quarters, so we see them all throughout here, and then this field here, even in our less weedy year, those are really all a whole bunch of lamb's quarters in there. This is the only one. We saw field mint popping up in our field as well. Chickweed, so I imagine this is not very good on either of those species. One thing I forgot to mention is I am only listing the species that we saw, not the species we didn't see. I don't know, like field mint may have been in those other plots and those herbicides may have controlled it, but I don't know if it was there, so I cannot comment if it's effective on some of those other weed species that I didn't mention. I'm only noting the ones that we saw that were there. So just to tell you that it's not effective or as effective on some of these. However, again, marketable yield was equivalent to weed free. So even though it's not really getting those early emergers, it seems to be, at least in our trials, we seem to manage to maintain a decent level of marketable yield. Next is Sencor STZ. This is kind of the hot new one that everyone, or I was getting a lot of questions about a couple of years ago. So this is a group 5, that's your metribuzin plus 14, which is again that inhibition of protoporphyrinase oxidase, which is similar to fomasate from the reflex, and that's from your sulfentrazone. Now, sulfentrazone is also marketed by its own as Authority. It's got used in a variety of horticulture crops. And if you have any experience with that, you know that STZ can have many interesting interactions in the soil. STZ is almost entirely degraded by microbial activity. So if you look at the half-life of that product, it varies between something like 150 days and 750 days. And it's because, unlike some of our other products, which might be degraded by sunlight or temperature or other very environmental effects, sulfentrazone, you're relying on microbes eating this product, basically. Use rates are between 157 and 219 mils per hectare, and you want to go with a higher rate for longer season varieties or heavy weed pressures. Uptake of sulfentrazone is primarily via the roots, same as metribuzin, and it will not control emerged weeds. So if you have PS2 inhibitor or triazine, metribuzin, Sencor resistant species that have emerged, STZ is not going to control them. It has no activity on emerged species. So while this product may have post-emerge activity, that's all coming from the metribuzin or the Sencor. And so if you're dealing with resistant species, this is not going to control them. However, if they have not emerged, it will. You will get that sulfentrazone will control lamb's quarters and pigweed species. So if they are resistant, they haven't emerged, this product should work on those. So this can be a resistant management tool. As well, it's effective on wild buckwheat. Couple of, no, okay. It can be applied anytime after planting, provided a minimum of 1 inch of soil is covering potatoes. Again, do not let this product touch your potatoes. And they say on the label to allow the soil to settle after hilling. There's no clear definition of what settled means. Mm-hmm. We applied it in both years, both locations, the same day, within an hour or two after hilling, and we didn't see any issues. We saw no phytotoxicity. So yeah, not really sure what that means, but at least in our conditions, with russet Burbanks, we didn't see any effect when we went in maybe 2 hours later. Do not soil incorporate this product. Do not apply to fine textured soils with organic matter less than 1.5%. Do not apply to soil with greater than 6% organic matter. This all relates to that microbial activity. When you have less organic matter, you're going to have less bioactivity in your soil. So less activity or less microbes there to try and eat away at that sulfentrazone and remove it out of the environment. And then when you have very high levels of organic matter, you have very active soil, so it may not be as effective. Do not apply to soil with pH of 7.8 or greater. And it requires rain or irrigation for maximum effectiveness. Now, sulfentrazone is persistent and can last in the soil for years. Said the half-life varies. I think it's reported up to 750 days for the half-life. So that's almost 2 years. So yeah, wait 24 months after applying STZ to a field before reapplying it. However, if drought occurs in any of those years, delay use of STZ by further number of years equal to the number of drought years. So if you apply it this year, you need to wait 2 years. But if within those 2 years, one of those is a drought year, delay applying STZ by a further year. If both of those are drought years, delay it by 2 years. If you get 2 years, then you get 2 more drought years, you need to delay it by a further 2 years again. And this has all got to do with that microbial activity. When you have drought, you're gonna have less activity or less bioactivity within your soil to take that stuff away. Resistance to STZ has been documented in wild oat in Manitoba and then ragweed in Delaware, just a little closer to here. And again, consult the label prior to use as always. This product, when we used it, it worked very well. So this is in our heavy weedy year with triazine resistant lamb's quarters. That's a very clean field there. And then again, in 2019, pretty clean. We do notice a little bit of low cudweed and some smooth crabgrass, but I don't think low cudweed is really much of an issue. I don't see it as one being as highly competitive. Again, we get marketable yield equivalent to weed free, so this was a very effective product for us.
Any questions about STZ or the last couple that we've talked about? I know there's been a bit of Sencor STZ being used on the island in the last couple of years. There's one in the chat. So any plant back restrictions with STZ?
I had this question earlier. I forgot to include the recropping interval. Yeah,
deal with that one first.
The drought?
Yeah, no, the plant back.
Yeah, yes, there's planting restrictions. I would consult the label. I can't remember what they are, but yes, there's significant replanting restrictions on STZ. Then I think, yes, 2020 would be considered a drought year. So yeah, I think. So I guess if 2020 was a drought year, mm-hmm. and you were on a 3-year crop rotation, mm-hmm. then in theory, you should be okay to use it the next time you plant potatoes in 2023. Yes.
Provided that one of the next 2 years is not also a drought year.
Yeah. Yeah.
And then that would
then
throw it off again.
Mm-hmm. Yeah. So this, especially with kind of our variability in environments, and some years we may get a drought, or it seems like we're getting more and more of them. You know, this may not be something that you can include every year or every cycle within your potato rotation, but maybe include it as a break. So instead of using Linear every single time in potatoes or Sencor alone in potatoes, introduce this second mode of action in there within that one cycle to try and help clean some of those issues up. And then maybe next time when you get to your potato year, you don't need to use this product.
Particularly if you're having a big problem with lamb's quarters.
Yeah. And so this would be, if you know you have resistant lamb's quarters, this might be a good strategy to try and help clean some of those up as you go forward.
I do think there was some discussion this morning about, I think there's some plant back restrictions on STZ, particularly around forages.
And mustards.
And mustards, like brassica crops.
Yeah. So be conscious of that and adapt rotation based on, or if you're going to use this product. We planted buckwheat in this field after with no issues. And then in this field this year, it was oat, and we didn't have any issues there. But we did not, no winter cover or anything there. So this was the following year.
Yeah, it's Gavin here. I got the rotational stuff up on the computer here, and yeah, basically 12 months for alfalfa, and some of your cereals might be the issue. Canola might be an issue as well too. But there's a lot of crops that it's safe on, and that's maybe part of the problem, is that you're going to be running into using the authority version of the product in some of your other rotational years. So that's something to keep in mind, that you may not just need to decide when you'd drop this in the program, if you're going to use it in your potato year, or if you're going to use it in your, if you're doing pulses or that kind of stuff. It might sneak into those rotations a bit more too, or soybeans even too. So.
Okay, thanks, Gavin. So moving on to some true post-emerge products. So these are applied post-potato emergence, very limited. So really limited to grass herbicides. So we've got there, clethodim, pretty sure Excel and Venture are not really used and maybe not sold, but they are on the list. So I just included them there. And then post, cethoxidin that I have some experience with. And then there's Prism, and then Titus Pro, which is rimsulfuron with, or is just Prism with Sencor tank mix. And so, yeah, we're just going to quickly go through these. In terms of your grass herbicides, these are all group 1. These are your ACCase inhibitors. This enzyme is not present within broadleaf species, so these products should be safe on broadleaves. I've heard some reluctance of producers of using things like post on potatoes, because they'll tell me phytotox issues, and I don't think it's related to the actual herbicide, but maybe the surfactant or something else in there. This is entirely post-emergent control. The use rates are going to vary based on your product. So I have clethodim there, that's Arrow or Select. So yeah, widespread resistance has been documented worldwide. Like out west, it's very challenging to try and control many grasses with any of these, but always consult the label before using. And there is some variability there. So like some of them are better on annual grasses, and some of them will get your perennial grasses as well. Next, Prism rimsulfuron. Got a lot of questions about Prism last year when most people's pre-emerge products did not work very well. It is a group 2 ALS inhibitor. All of your group 2s have very low use rates, so this one's 60 grams per hectare. You want to make sure you use surfactant here, because you want to maximize the efficacy, get that product in and across that waxy cuticle on those plants. You want to apply it from emergence, or you can apply it from emergence up into prior to initiation of flowering. And this is really a post-emerge product. It controls a lot of annual grasses, and then gives you a little bit of control of pigweeds and lamb's quarters. However, they need to be very, very tiny. We're talking like 2 to 3 true leaf stage. This product will control PS2 inhibitor resistant biotypes, group 2s. That's an entirely different mode of action than your photosystem 2 inhibitors. So yeah, if you have any emerged resistant lamb's quarters, this should work. I cannot kill lamb's quarters with Prism, and I can't do it in the greenhouse. So I'm not sure how effective it really is. I've gone like 10 times over the label rate, and I still can't control them. So yeah, not the greatest, or not the most efficacious. Absorbed through the leaves, and it is translocated throughout that plant, and allegedly will provide control until canopy closure. You can tank mix this. Oh, sorry. Yeah, injury to potatoes may occur if previously stressed. So be conscious of that. If you're using this product, it's a good chance, because there wasn't too much, or there wasn't enough rainfall to get good activation of your pre-emerge product. So those potatoes may be already stressed. So it may see a little bit of injury when going in and applying Prism after. It can be tanked with Sencor to improve control, to try and get, some of those other things that Sencor will control. And looking at the literature to try and any way to try and improve the control of Prism on lamb's quarters, and everything says tank mix it with metribuzin or Sencor. If you're dealing with resistant lamb's quarters, that's not going to work. That doesn't make any sense. So if you have resistant lamb's quarters, this product, tank mixing it will not help make it better. It is susceptible to leaching in sandy soils, and it may contaminate groundwater if water table is shallow. So do not apply if heavy rain is forecast. And I'll show in a second, we have widespread resistance to group 2 herbicides. This chemistry seems to develop resistance within 2-3 generations, or can. Okay, so that's the herbicide stuff. I'll stop here for a second if you want, if anybody has any questions, and then we're going to move into talking a little bit about herbicide resistance. All right. So I hope nobody's ever seen a field like this, or one of their fields looking like this, but this is one of mine with a very heavy infestation of lamb's quarters at our research farm. And there are potatoes in there, but not many of them. So yeah, this is, when you can end up with triazine resistant species, this is the kind of situation you can end up with. As well, these are all pictures from our research farm. This is Dave Main's scab nursery. And those are all very happy little pigweeds emerging after an application of Sencor. We haven't done the actual testing on this yet, but I would imagine this is triazine resistant pigweed. And then here, this last picture here on your right, all of that is just dead corn spurry, and all of that green is pretty happy lamb's quarters coming through after an application of Sencor. And this is all, again, at Harrington. So we have it all over our research farm. Yeah, so we're not immune to it. This is some data from Dr. Ian Heap. He maintains the International Survey of Herbicide-Resistant Weeds. Great database, great resource. But yeah, so this is going back to 1950 when we first documented our first herbicide-resistant weed, which was 2,4-D, or sorry, wild carrot-resistant 2,4-D in Ontario. And then in the 70s here, we started to see some atrazine and triazine resistance, and then it's just really exploded over the last 30 years. And now we're up over 500 unique cases. Breaking that up by modes of action. Here, mentioned group 2s, you get resistance really quickly. These products started coming on the market in the 80s and the 90s, and then resistance has just skyrocketed since. This dark blue line here, this is your triazines. So when atrazine was used a lot and then kind of leveling off. Then the 2 other ones I just want to point out, this green one here, those are your grass herbicides. So those, those group 1 grass herbicides. And then this blue line here, this is glyphosate. So glyphosate in Roundup Ready crops, first introduced in 1996, first glyphosate resistant weed identified in 1996. And it's just kind of increased since with the proliferation and overuse of Roundup Ready crops. So we've been working on PS2 inhibitor or metribuzin Sencor resistant lamb's quarters. And basically, as long as you look hard enough, you will find resistant populations. So each one of these squares here is a different field. Lamb's quarters we collected from a different producer field. This concentration of red right here, that's Harrington. And each one of these green ones is a population that is still susceptible to Sencor, so it still works. And each one of these red ones is a population that is resistant to Sencor. So really, wherever we look, we can find resistant populations. How does a resistance develop? Well, it's really an oversimplification of cropping systems. So reduced reliance on things like cultivation and shorter crop rotations. Anytime you're removing different tools that you used to use and relying on single mechanisms of control and reliance on single modes of action, you're inevitably going to select for resistance to whatever that strategy is. This is just natural selection playing out in front of us. So, where we've got a lot of issues, particularly around glyphosate resistant weeds, it's entirely these systems of no-till, Roundup Ready corn, Roundup Ready soybeans over and over and over and over again. And so no cultivation, no rotation, single mode of action, you're going to get resistance. It's you're applying the strongest selection pressure you possibly can onto these plants. You spray herbicide, it's going to live or it's going to die. And if it survives, it's going to reproduce or it's going to set seed. So How that looks in practice, you can end up with just random mutations happening, or you do end up with random mutations happening within your populations. If you think of a lamb's quarter or a pigweed plant, single plant can produce 500,000 to 2 million seeds. So a huge amount of potential for variability, and then you look across a field and you may be dealing with a lamb's quarter density of, you know, like a 500 to 1,000 plants per square meter. That's an enormous amount of seed and an enormous amount of potential for just these random little mutations to occur. And then you go have an individual that happens to have a mutation that confers resistance, use a product that it's now resistant to, it survives, produces seed. Next time through, when you use the same mode of action, it survives again, produces a bit more seed, and then really end up with this kind of situation where all those dark green ones would be resistant ones, and kind of taking over that full field. So when you're actually looking for herbicide resistance, a couple of key questions you can go through. Has the same herbicide mode of action been used repeatedly on this field? This is not just same product, but same herbicide mode of action. So if you're constantly using group 5 products, that's your Sencor, that's your atrazine, you will select for resistance to those groups of products. Same goes for glyphosate, same goes for everything. Next, did the same rate previously control this weed? So, you know, we know there's very different levels of susceptibility in our weed species. And some are controlled at very low rates, some are controlled at high rates, but if we start to see that a rate that previously controlled it is no longer controlling the species, then we may be dealing with some form of tolerance or resistance. Are there live and dead weeds following application? This gets to issues around actual application. You know, if everything is alive within a field, all your species are alive, it's probably more to do with something to do with the actual application than resistance actually being in that field. Next, we noticed a recent decline in control. That's related to this. This doesn't happen in a single year. This happens across multiple years. So if you go into a field and you're noticing a patch, and then next time through your rotation, the same mode of action used, that patch gets a little bigger, and a little bigger, and a little bigger, you might be dealing with some kind of resistance. And really important, are other weed species being controlled by this rate? So if you get into a field, think of that picture I just showed where there's a whole bunch of corn spurry laying dead in the field and then just a whole bunch of lamb's quarters popping through. That's a single species that seems to be surviving it that normally would be controlled. That's a good indicator. What it can look like, so these are some of our plants that we applied metribuzin post when they're at 2-3 leaf stage, and they get a little crispy from photosystem 2 inhibitor, but then they just simply grow out of it. And just an observation, this phenotype tends to be a lot taller, doesn't really branch, but that's just an observation. So they kind of look like that, but that's not, I would not try and use that for diagnosing this in the field. You really cannot diagnose this in the field. So yeah, how you actually can identify resistance. We started doing resistance testing in 2017, just collecting seeds from anybody who'll give them to me, really. Planting them out in our growth chamber, and then we spray them with increasing doses of either Sencor or Linuron. So the two major products that we're interested in, both photosystem 2 inhibitors, but I mentioned they're at different sites. This we call site A, that we call site B. We treated our plants at this stage, so this is the two true leaf stage. So we are trying to apply it post just so that we know how many plants we're actually dealing with here. So we treat these and then we monitor them for the next couple of weeks and then collect biomass after 3, 4, 5 weeks. I think this is after 6 weeks. And here we've got metribuzin rate across the x-axis. This is in a log scale, and that's just so that we can put it all nicely on a graph. And then on the x-axis here, we've got biomass expressed as percent of our weed-free control. So in our control. So when we didn't apply anything, you get 100% biomass. And what we're looking for is we want all of those lines to be below this line, which would be 90% control, reduction of 90% biomass at the rate that people are using in the fields. If we look at the rate that's typically used, we're at around 0.5 kg per hectare. Not a single one of those lines except this, which is our known susceptible, would be controlled by that rate. So it's saying that every population that we looked at would not be controlled in a producer's field with the rate of Sencor that they're using. You can see here you can control them, but that's at 10 kgs per hectare. So that's over 10 times the label rate. So not something you'd ever be able to do. But yeah, what's normally used within fields, you're not going to see good control or really any control there. Now, we can get into a little bit of resistance mechanisms, and there is a reason why this is important. So the most common form of triazine resistance worldwide is what's known as the serine to glycine 264 mutation. It has evolved numerous times, numerous species worldwide. It is the most common form of triazine resistance. However, there are a variety of other mutations that confer triazine resistance, and these are all within this PSBA gene. And so that is, that's your gene responsible for, or it's the target site for that product, for your photosystem 2 inhibitors. So we're dealing with that serine 264 glycine. It's found in numerous species worldwide. And then here we've got a cross resistance pattern. So here we've got atrazine and Sencor. So these are two group 5 products. Then we have Lorox here. This is a group 7, also a photosystem 2 inhibitor. And then we have bromotril here, or Pardner, bromoxynil. And that's a group 6 product, also a photosystem 2 inhibitor. So we've got 3 different photosystem 2 inhibitors, but they all work slightly differently. So your group 5s between these two, atrazine is a true triazine product versus Sencor is actually a triazinone. So they bind slightly differently to that site. So with that serine 264 glycine, it actually changes that pocket where that herbicide binds and prevents binding of atrazine. So our populations that have this mutation, you cannot control them with atrazine. It doesn't really matter how much you put on that plant, you are not going to control it. But we have moderate levels of resistance to Sencor. So when you get up to these insanely high level or high rates, 10 kg per hectare, you can control them with Sencor, but it's no way anything that you could actually do in a production system. Fortunately, our population's S stands for susceptible, so they seem to be still susceptible to Linuron. And they're still susceptible to these group 6 products. Compare that to this top one here. That's valine 219 to isoleucine. And this gives low levels of resistance to atrazine, moderate levels of resistance to Sencor, but moderate to high levels of Linuron. So if that was the mutation we were dealing with, you know, that's basically taking 2 of our main tools out of that toolbox. So fortunately, we are not dealing with that. It seems like everything that we've tested so far is all serine 264 glycine. But be aware that there are other mutations that give different cross-resistance patterns. And you know, there's no way to select for one or the other. It's really just kind of random, or appears to be random. But yeah, know that Linuron will still work on our populations. So how do we manage and try and delay or prevent herbicide resistance? It's really about changing things up. So here, crop rotation would be, crop and herbicide rotation are really your 2 best or 2 easiest strategies. However, it's not just crop rotation, but it's important to rotate herbicides within that crop rotation. So you could have a rotation that's potato, corn, soybean, wheat. However, you could use Sencor and potato, atrazine and corn, Sencor and soybeans, and then a group 4 product in wheat. So 3 of those 4 years, you're hitting those weeds with the exact same selection pressure. You are going to select for resistance. Even though you're switching up your crop groups, the rotation looks fine. The management strategies are the same, or the weed management strategies are the same. So you're going to select for resistance. Compare that to when you practice crop rotation and herbicide rotation. You may have potato, you use a group 7 product like Linuron. You move on to your corn year, you use atrazine plus Callisto, and then you get to soybean, you use Roundup Ready soybean, and then wheat, you go back to a group 4 product. So here, you're constantly hitting your weed species. Not only are you changing up crop groups, so you'd be selecting for different weed species to be present, but you're also going to hit them with different modes of action and different chemistries. So if you have things that are resistant to group 5 products, Well, you hope that in this case, the 27 is going to take care of it, but then in the next year, that group 9 is going to take care of it. So just to try and, even if you can't manage it within that year, maybe you can manage it within your rotation with other products that are affected or that are can be used in those other years. So managing resistant lamb's quarters in your potato year, focus on preventing weeds from setting seed. The most important year after identification of herbicide resistance in a field is the year that you identified it in. Because if you let those weeds set seed, that problem is there. If you can eliminate those before they set seed, then maybe remove that from the population and hopefully prevent it from reestablishing itself. A little bit challenging in potato, but multiple modes of action with the correct herbicide rate and correct time. We talk a lot about tank mixes, but simply putting 2 products in a tank is not a tank mix. That is, I mean, technically it is a tank mix, but it's not a true multi-mode of action tank mix. True multi-mode of action tank mixes have products in them that at the rate that you have them in the tank are both going to control particular weed species. So if you think of like that boundary LQD, you've got your group 5, you've got your group 15 in there, but only one of them is effective on lamb's quarters. Not your group 15 is not. So you don't have a true multi-mode of action tank mix there. So you want to try and create that tank mix, and within the potato year, it may be not feasible, but when you're building these tank mixes, it's important to try and incorporate products from different modes of action that are effective on the same weed species to try and, if it's resistant to one, this thing will take it out instead. As well, I think there's still a place for mechanical management. I know a lot of people, there's a drive for minimal soil inversion, reduced tillage, no-till, don't disturb the soil. But mechanical management I think still has a place. So it is like going in and hilling is a weed control, or it is weed management. You are chopping everything off and killing all those annuals that are there. So maybe going back to once every couple of cycles in your potato year, maybe delaying, like not doing the 1-pass hilling, go back to the 2-pass. It could be a strategy if you're dealing with heavy weed pressures or resistant species. Just trying to introduce a different, like mechanical management, you can treat it as a different mode of action there. So in the rotation years, good strategy can be to use competitive cover crops to try and suppress germination and seed shed. So I've got a little bit of data on that we'll get to in a second. And in these rotation years, it might be a lot easier to try and build in that multi-mode of action tank mix, again, but at the correct rate and correct timing. And another really important thing is prevent new weed seed introductions. So there's a reason why certified seed exists. It is certified to be weed-free as well. I think it's 99.5% certified to be contaminant-free. It obviously isn't. There are some weed seeds in there, but using weed-free seed or certified seed is going to give you, you get a guarantee when you get that blue tag there. As well as, I'm not sure, I've never looked into it, but cleaning equipment, I don't know about the situation in potatoes of how much transfer of weed seeds is going to be happening. If you just think about how a potato harvester works though, I imagine there could be quite a bit of potential for that. But I've seen quite a bit of work from some of my colleagues who work in the blueberry world, and this is a major source of introduction of novel weed seeds from field to field as you move that harvester around. And simply pressure washing your harvester in between moving from one field to the other, or pressure washing the tires, anything like that can be really effective at preventing weed seeds from moving around. Again, I don't know how big of a deal it is in potatoes. I haven't looked at it, but I imagine just looking at the equipment that there is potential there. Okay, we're going to move into some of our data from some of my projects working on with my graduate student, Laura Anderson. So this data here, this is looking at, just to give you a little bit of context, here we've planted a cover crop, a full season cover crop in the year before potato. And so we planted either brown mustard, buckwheat, a mix that consisted of hairy vetch, annual ryegrass, and crimson clover, and then straight seeded timothy. And we grew those as full season cover crops, and then we terminated them in one of 4 different ways. So we either just mowed them off just with a flail mower. We used a roller crimper bar and rolled them to try and terminate them, or we mowed them and then disked them to try and soil incorporate, or we used a high rated glyphosate. So whatever the highest rate is, I think it's 1.5 liter per hectare, just to try and terminate them. And so what you're looking at here is the weed density per square meter in the potato year, so in the subsequent year. And these are all of your cover crops by all of those termination methods. And in the potato year, we did no weed control. So we planted and then we hilled, and that was it. So we were completely relying on the previous year's cover crop and the method of termination of giving us all of our weed control. So what we find, brown mustard and buckwheat tend to shine above the rest in terms of their carryover effect on weed suppression. So there's no difference in terms of, or no statistical difference in terms of how we terminated that buckwheat. It didn't matter. Buckwheat's just good at suppressing weeds, and equally as good as brown mustard. Compare that to this multi-species mix, that three-way mix, that produced an enormous amount of biomass. I was really thinking that that was going to be the one that shone through. It wasn't. So, you know, we get even though we produced a ton of biomass in that previous year, it didn't seem to carry over in terms of weed suppression in the following year. And then Timothy is not surprising. It's pretty slow establishing, not very competitive. So not surprising that it wasn't very good. What I'd like to highlight here is the effect of disking in these cover crops. So while we don't see it with buckwheat, we see brown mustard, the mix, and our Timothy all reduce the amount of the subsequent weed density when we disk them in the previous year. Now I hypothesize it might have something to do with effects on seed germination. So why we plant brown mustard generally is to try and take advantage of that biofumigant effect on wireworms. What's not really talked about though is the biofumigant effect that brown mustard has on weed seeds. And it can be used and there's more and more literature coming out showing the biofumigant potential of brown mustard against a variety of weed seeds. So that's what I think may be happening here when you actually incorporate that brown mustard in, is it's having some sort of like not bioherbicide, but biofumigant effect on those seeds. We are working on the seed bank story right now. Seed bank work takes a very long time. So that data is still, we're kind of working through it right now. We had a bit of a layoff, 6-month plus layoff. So that kind of interrupted our ability to get that, but I'm trying to hammer that story out because I think it might have something to do with suppression of viable seed shed and seed germination.
Just one more thing I'll add to that, Andrew, too, on the cover crop, a preceding crop and its effect on weeds. So we've also seen, or I've heard quite a few growers talk about the weeds being less after buckwheat, after mustard, after Sudan grass. So I had some discussions about that. A question that's come up a lot is the multi-species mixes. And without necessarily taking a pro or con on those, I will note that I think it depends a lot on what's in those multi-species mixes. And I have had some discussions with growers who had a lot of buckwheat in those mixes and then didn't mow them very quickly. And buckwheat can set seed in like 6 weeks. So then they had a lot of buckwheat go to seed, and then it came up in next year's potato crop. So that's just something to I think when you're picking what you're going to put in your multi-species mix, I would be, rather than just get one off the shelf, I would be picking what suits your potato production. What's not going to make verticillium and nematodes worse, what's not going to set weed seeds in potato crop, that sort of thing. And then the other thing would be, I also, again, you said about using certified seed, and I do know some stories from last year of, again, people with multi-species mixes that they're pretty sure brought in mugwort into some of their fields. And mugwort is very hard to kill and very, it's a big problem. So again, I think knowing where your seed is coming from, and making sure you use certified seed, clean seed as much as possible, just to make sure you're not bringing in a problem.
Yeah.
We all got enough problems. We don't need to bring more in.
Mm-hmm. Yeah, and that's so within all my kind of weed science colleagues within our region, Gavin's part of this. We will often get, here's a picture of a weed. I don't know what it is, from an agronomist or a producer, and so we'll send it around amongst each other. And yeah, there's some pretty weird things that pop up in cover crop fields. I think there was a blue weed related to Phacelia that popped up that none of us had ever seen before, except I think Gavin had come across it in a cover crop field. And so, yeah, it can for sure become issues.
Any other questions? Any other questions for anybody? Okay, drive on.
All right. Okay, so this is a little bit of work from, again, from my graduate student. So she's working on whether or not we can, again, as a seed bank management strategy, try and control lamb's quarters that are overtopping the potato canopy. So here, I'm not sure, how many of you may be familiar with a wick bar or wick weeder, weed wiper, but there's a couple of different models and various manufacturers. But the one that we used is simply just a PVC pipe with a whole bunch of wicks sticking out of it. And then we feed in and fill that pipe with a very, very concentrated glyphosate solution. So this is a 33% glyphosate. So 2 part water, 1 part glyphosate. And then you just move this across over top of the canopy, and wherever it touches, whatever it touches, it drops a couple of drops of glyphosate on it, but you're at such a high concentration that a couple of drops are more than enough to take a lot of these things down. So here we're trying to see, we've accepted that yield is gone, yield potential is gone, but we still want to try and harvest that crop, and we want to try and prevent this stuff from setting seed. Oftentimes in IWM, we talk about the little hammer approach. That was like a big thing of my supervisor, Clarence Swanton, always on the little hammers. I consider this potentially maybe one of those little hammers, so something that could have some sort of effect on the seed bank. Yeah, so we loaded this up with glyphosate, and then I will mention we have a reciprocal experiment to this where we, instead of using a wick bar with glyphosate, we use hedge trimmers and just went at the same height and to simulate like an above canopy mowing to try and chop those off to try and get something. Because I realize this is not something that I can tell a producer to do right now, because that would be probably unwise. So yeah, we try and maximize that gap between the potato canopy and our target because we do not want glyphosate getting on potatoes. Glyphosate gets shunted to potato tubers. If you've ever seen glyphosate on potatoes, those potato tubers look disgusting. So yeah, this is right after application, or probably a week after application. You can see some crispy lamb's quarters there. Then one thing we did to try and evaluate the actual effect on individual lamb's quarter plants is the day after we applied this, we went in and bagged lamb's quarters with just a plastic low density polyethylene bag that is permeable to water, CO2, and H2O, so that we can hopefully not kill the thing or create a greenhouse effect there. And because we wanted to try and evaluate the effect on we wanted to capture the entire seed production of that individual plant. So we put that bag on there to ensure that we would actually be able to get all of the biomass. And then we monitor these for the next couple of weeks. So this is what a lamb's quarter looks like 1 week after, and then this is 2 and 3 weeks. So you can see really, like, even though we just got a couple of drops on these things, it really goes down. Okay, moving on to some of the data here. We've got lamb's quarter biomass on the y-axis here, and this is grams per plant. So this is an individual plant. We've got our 3 treatments. So this is control, untreated, and then our early and our late timings. And this whole bar here, that entire bar, represents total biomass. Then we've divided this up in between the vegetative biomass, so this lighter section down here, and vegetative biomass is the stem, leaves, and petioles. Then above this, that darker green color, that's the reproductive biomass. So that's all the seed output. And then we've calculated essentially a harvest index. So harvest index is something that's used, it doesn't really make sense in potato, but use it in corn and soybeans quite a bit. And it's simply the ratio of reproductive biomass by vegetative biomass. And so saying how much the percent of the biomass being allocated to reproductive effort. And in corn and soybeans, you're usually around 60% of the biomass goes to actual yield. In lamb's quarters, in our control, it looks like it's around 4%. So not really very much. But then when we compare that to our two treatments, we can see in our early treatment, we reduce that by 74%. So we go from 4% allocation down to 1%. So really reducing the amount of biomass that's being allocated to the seeds. So reducing seed output. Not only are we reducing seed output, but we then took those seeds and then evaluated germination percentage. So that's the actual fitness of those seeds. And so here we've got lamb's quarter germ on the y-axis, and again, our three treatments on the x-axis. And lamb's quarters in general have between 50, 65% germ. But when we looked at our early and our late applications, we were able to reduce that by 20, 30% compared to our control. So not only are we reducing the amount of seed that's going into the seed bank, but we're reducing the fitness of that seed. So it looks like that would suggest this may be a strategy that could be one of those little hammers to try and reduce that. It's okay, right? Try and reduce seed shed. So that's all I wanted to talk about today. Just highlight a couple of resources. One, the PEI Potato Guide. So that's Larry McKinnon's from the province. Every single product I talked about today is in there, along with a table highlighting some of the major weeds and how effective they are on those, as well as your timings in potato and all that. So as well as, this is not just for herbicides, this covers your insecticides, fungicides, everything. So great resource. As well as I'd highlight Ryan's, the PEI Potato Board's agronomy website. We're trying to populate more and more weed stuff in there. Right now, we've got two great resources from Gavin on volunteer potato management and then weeds in potato. Then my lab produced a fact sheet on management of triazine-resistant lamb's quarters just this past year, or last year now in October. So that's hosted there. So it goes through all the experiments that we've done so far on chemistry. And then the last thing I'd highlight is Omafra Pub 75. So they've recently split it into two. There's 75A and 75B, but this is really your weed control Bible. 75A is your field crops, B is your hort crops, so this is probably the one you're more interested in. And every single product that's registered for use in Ontario is in there. Tons of information about them, use patterns, recropping intervals, efficacy on a variety of different species, all in there. So I highly recommend that resource. You can purchase it online. I think it's like $30, or you can download a free PDF. Everything, as far as I'm aware, pretty much everything that's in there would be registered for use out here as well.
I just downloaded a copy.
Perfect. Yeah. Yeah, I have I've outfitted my team with them. So yeah, it's a really, really good resource. So yeah, with that, I just want to thank my technician, Nicole McDonald, my graduate student, Lori Anderson, all our summer students, farm crew, and then I'll just highlight Gavin, Sebastian, Martin Laforet, Sheldon Hahn, and Cameron Wag, who all helped with this project, as well as this is all funded by AAFC, so just highlight them. So thank you, and I'd be happy to take any questions. If you don't want to ask anything right now, feel free to email me. I will do my best at getting back to you. So thank you.
So Morgan, I think I'll get you to take the share screen off, and then if anybody has any questions, definitely encourage you to ask.